आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़।
Celebrating Azadi Ka Amrit Mahotsav, we bring you a podcast series on STEM popularization, science, technology, engineering, mathematics and medicine, supported and catalyzed by the National Council for Science and Technology Communication, Government of India. This program is produced by Media for Community Foundation. Creative content and technical support is given by Purvasha Banerjee and Shushanto Das.
एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़, की आवाज़।
Vigyan Ki Awaaz podcast series aims to popularize new ideas of science and technology, which highlight STEM, science, technology, engineering, mathematics, and medicine. This brings to the surface the efforts and researches of Indian scientists, which is desired to bring a change in community learning and teaching, access to knowledge of resources, and social paradigms. Our goal is to spread the name of indigenous Indian research stories and their masters among the masses of society in a very easy manner. Bose Institute was set up in 1917 by Sir Jagadish Chandra Bose, the founder of modern science in the Indian subcontinent. It is Asia's first modern research center devoted to interdisciplinary research and bears a century-old tradition. The institute was founded as not merely a laboratory but a temple, with its principal aims being the advancement of science and diffusion of knowledge. Swami Vivekananda, Sister Nivedita, whose influence is reflected in the institute's emblem of Vajra, was significant in the setting up of the institute, and Rabindranath Tagore were among those who had consistently inspired and supported Jagadish Chandra Bose in his endeavors. Ever since the establishment of the Department of Science and Technology, Government of India in May 1971, Bose Institute has been an autonomous grant-in-aid institution of DST. Over the last century, the institute has endlessly strived to preserve the legacy of its illustrious founder. We welcome Professor Smarajit Polley, who is an assistant professor at Bose Institute. He shares about his days as a student and his journey as a scientist and professor.
I am Smarajit. I am an assistant professor in Bose Institute right now. I did my bachelor's in chemistry major from University of Kolkata and the master's in biochemistry from University of Kolkata. But then I did my PhD from Bose Institute and IICB because my lab moved from Bose Institute to IICB in structural biology. So in my PhD, I was looking at NMR spectroscopy and fluorescence spectroscopy of macromolecular interactions using some of the proteins that are directly related to diseases. For example, I used to work on a protein that comes from the Indian cousin of Japanese encephalitis virus, and also with a protein called P53, which is very important in human cancers.
Sir explains about his research in simple words.
So I'll talk about our research a little bit in as simple as possible manner. So I'm trying to set up research theme in this institute based on cryo-electron microscopy. So cryo-electron microscopy is the leading technique to determine the experimental macromolecular structures. So this technique received Nobel Prize in 2017. So what is so special about this cryo-electron microscopy? The specialty of this technique is that it needs very little biological sample. Earlier methods that determine the macromolecular structure, for example, X-ray, it required a huge amount of biological samples that are not easily available. So cryo-electron microscopy has reduced that requirement, and it's a microscopy technique based on electron microscope. So you might not be aware that the electron microscopy in India actually originated in Calcutta. So the person who made the first electron microscope in Asia was in Calcutta. So that it's a great thing that many of the people don't know that it started actually in Calcutta. So what happened is that this method was not as popular because it's very resource intensive, in the sense the microscope is very expensive. So when I came back from US, I worked in University of California, San Diego and Salk Institute. There are not many people who knew this technique. But the interesting thing is, in the last 10 years or so, something like this, community has grown. So many people are coming back, and India is actually taking this very seriously to make a mark on this technique. So what happened is that in 2020, when the COVID struck us, so everybody was kind of depressed, but ACRB did an excellent thing. So they came up with a project where they would fund 4 such microscopes. Okay, so the scientists were relentlessly working. So they came up with this project, and they chose through a competitive grant 4 different institutions all over the India to fund one such microscope. Without this microscope, you cannot do it. So Bose Institute is one of them. The other 3 centers are IIT Madras, IIT Bombay and IIT Kanpur. So I think this instrument will revolutionize the field that is already in a very positive mode in India.
Professor speaks about India's contribution in this field of research.
So I think what happened is that other places, the other countries, they were already moving ahead. But we started late, but I can say the human resource that we have, the scientists, the trained scientists who are coming back, and with this ACRB's new theme, and other agencies are also stepping in, like DBT, they're setting up centers. And CSIR has already set up one center in CCMB, they set it up earlier in IICB. So I think we are going in a very positive direction.
Professor carefully explains the significance of his research for human welfare.
So it is a very relevant question, and as Shubhro was telling you that they look at the small changes through computer, and those small changes make one good protein a bad protein, right? Something that is needed for your well-being, with the small changes, they become actually harmful. So those changes that they simulate on the computer, you can actually look at them through this microscopic technique, that how exactly, what are the exact changes. And that has a huge impetus for the pharmaceutical industries. Because, for example, many of the drug targets that say it can be cancer, it can be diabetes, it can be autoimmune disease, it can be antimicrobial resistance. So those small changes, what exactly those changes are, how exactly those protein molecules looks like, because in our cells are nothing but a community of different macromolecules, and proteins are the most important part in those. And small changes in those proteins can lead to catastrophic outcome. So those small changes, as Shubhro was telling, you can determine, you can model them through computation. And through this microscope, you can actually look at them, how exactly they're looking at. So you can get some idea that what are the proteins that are causing this disease, and you can look at those proteins in this microscope and see that what are the exact changes. And the industry can use this information to design drugs against those, and that has huge implication for healthcare be it in India and or worldwide.
Professor also talks about the wide application of the technique developed through his research.
As I said, this technique has wide application. Any disease you talk about, be it cancer, be it diabetes, be it autoimmune disease, be it antimicrobial resistance, this technique can be applied everywhere. So the people in the lab, for example, Kaushik, who work on the basic mechanism how these diseases develop, they have to identify, yes, this protein, if this gets bad, then you have the disease. He gives me the protein. I look at them in the microscope and I tell him, this is the changes that are happening that is making the bad protein a culprit. So it can be employed in every disease, but the question have to be asked by other kind of people, and we give them the answer.
We sincerely thank Sir for his excellent deliberations.